You're cruising at 40,000 feet in a small business jet. Suddenly, the pilot slumps over the controls. For decades, surviving this exact scenario meant a terrifying gamble. An untrained passenger would have to grab the radio, find an air traffic controller, and attempt a highly complex, verbal talk-down landing. In older analog cockpits, you at least had physical dials and levers that offered a crude visual logic to how the plane operated. But modern aircraft rely on glass cockpits, digital screens packed with menus and automated flight modes that require intense, specialized training to interpret. When humans and complex automated modes conflict, the results are catastrophic. During a 1994 approach to Japan's Nagoya airport, a co-pilot accidentally triggered a go-around automated thrust mode while trying to land manually. The human and the machine fought for control of the pitch. The system became confused, and the aircraft crashed. To remove that burden from a panicked passenger, Garmin developed a system that takes complete control of the flight. With the press of a single button on the cabin ceiling, you activate Emergency Autoland. You no longer have to figure out how to operate a highly complex machine while hurtling through the sky. You just have to grant the machine permission to save your life. This image shows digital data overlays displaying runway size, wind, and glide path data. The moment Autoland is engaged, the onboard computer rapidly evaluates all these variables, along with remaining fuel and real-time weather conditions, to instantly select the safest possible destination airport. To physically fly the aircraft, the system relies on an attitude and heading reference system, or AHRS. This digital sensor suite replaces old-school mechanical gyroscopes, giving the flight computer highly precise spatial sensing, so it knows exactly how the plane is oriented in the sky. As it descends, the computer continuously cross-checks that spatial data with onboard radar altimetry. By bouncing radio waves off the Earth, the system maintains a perfect, real-time measurement of the aircraft's exact height above the ground. This visualization displays a red and yellow digital mesh mapping over a mountain peak. The flight system uses this exact kind of real-time terrain and weather mapping to actively steer around hazards, using automated throttles to control the aircraft's speed and altitude without human intervention. The digital co-pilot processes spatial data and makes navigational decisions with the accuracy of a highly trained human, but it operates entirely free from adrenaline, panic, or sensory overload. While the plane adjusts its heading, it automatically broadcasts its emergency status and intended routing to air traffic control on the correct radio frequencies. This screen shows a clear Emergency Autoland active message, alongside a simple graphic of a plane approaching a tower. Inside the cabin, the display switched to these plain language updates, showing the passengers their exact destination and arrival time, while instructing them to keep their hands off the controls. This image illustrates the precise geometric flight path the system generates for its final approach. If the aircraft arrives at the destination too high or too fast, Autoland will automatically enter a holding pattern, circling the airport to bleed off speed and altitude before lining up with the runway. It aligns with the runway centerline, flares the nose up at the exact right second to soften the impact, touches down, and immediately applies automatic braking. An incredibly complex sequence of physics, navigation, and terminal flight procedures was executed flawlessly, from cruising altitude to the tarmac, with zero human input beyond a single button press. Once the aircraft comes to a complete stop on the runway, the system automatically shuts down the engines and displays clear evacuation instructions on the cabin screens, so passengers can safely exit. Autoland is just one piece of a broader Garmin safety ecosystem called autonomy. If a pilot tilts the aircraft too far left, electronic stability protection gently nudges it back to stable flight. If cabin pressure is lost, emergency descent mode rapidly descends the aircraft, automatically leveling off at a safe breathing altitude. For decades, aviation design operated under the assumption that automation required constant human supervision. Now, the logic is flipping. We are building invisible safety nets directly into the software, ensuring that when the human fails, the machine is there to step in and take over.